Hello everybody. In this video we're going to be dealing with linear equations, but before I do go into examples, I just want to maybe go over some understanding. Maybe if you're having like an academic comeback or something, let's just try and guide you into why we do equations and why are we solving for equations and how do we have to understand everything about equations. Okay, so first things first, right? Think about this equation. Let's say 15 plus 15. What is this equal to? This is equal to 30. What we just did was we formed an equation, right? I know we don't have any letters or something like that, but just bear with me right now. I'm doing it in a way where you can just understand and we only have numbers for now, okay? So this is one thing, right? Notice that this side has to be exactly the same as the other side. Well, this one adds up to 30, but this side is also 30, so both sides have to be equal to each other. That is what an equation is. Okay? Equal on both sides. So when we are dealing with algebra, what we need to know in order to solve equations is that what we do on the one side of the equation, we have to do on the other side of the equation. So for example, in this part over here, let's say I will want to, let's say, add 15 again, okay? If I want to add another 15 here, I have to add another 15 here so that the equation can be true. Because remember, it's equations and not inequalities. Otherwise, we're going to have to deal with these signs and all of that, okay? That's inequalities. So these are equations. Both of them have to be the same on the same sides or both sides. Therefore, this will just be 15 plus 15 plus 15, which is equal to 30 plus 15, right? Because we added the 15 on the other side. Now, let's just add them all together to see if they give us the same thing. They should actually, because 15 plus 15 plus 15 should give us 45, and 30 plus 15 should also give us 45, okay? So this is the whole idea of what you do on the one side, you have to do on the other side. Think about fractions, right? What you do on the top, you have to do on the bottom, because at the end of the day, they need to cancel out. But if you need to manipulate the fractions in a way where you can use maybe some rules or properties or identities when it comes to trigonometry, then this is where manipulation comes through. Okay, so we use this idea in equations and just about anything in algebra, the manipulation. And this is what I wanted to give an idea towards with you. So what if we have an unknown variable and we need to solve for something? Let's get into that part. Okay, so here's our first example. X plus 15 is equal to 30. Now, I know what you're wondering. Yes, we just did this. But I want to see now if what we understand can now be applied when letters are involved. So we don't have to be so stressed out, right? So think about this, right? We need to find a way to get rid of this 15 on this side, because we need to figure out how to get x on its own so that we can see what x is exactly equal to. Because remember, in the example that I did earlier, we needed to see if the one side was the same as the other, meaning if we can get x on its own, we can see what value it is actually equal to. So therefore, what we can do here is we can just minus both sides by 15 so that we can get rid of this 15, right? So if we do it by 15, so minus 15, then minus 15 here, then what's going to happen is we are going to get x plus 15 minus 15, which is equal to 30 minus 15, right? And then from here, notice that 15 minus 15, they just give us 0. They cancel out. Therefore, we're left with x on this one side. And then we have 30 minus 15, which should be 15, which that is true. Because if we do plug it back in, notice when we plug x equals 15 into the equation again, we have 15 plus 15 is equal to 30, which is true. Okay, so it fulfills this equation. And that is the whole point of now solving for these equations, because this is in the whole idea of problem solving. How can we now isolate something to make things a lot easier? So this first method that we used is going to be subtracting both sides of the equation, and we can even add both sides of the equation by something just to get rid of something else. Okay, let's do one more example of this part, and then we'll move on to the other methods where you can solve for x with linear equations. So I know this one looks very easy because you can clearly see x minus 20 is equal to 40, and we can clearly see that if we fill in the blank, notice that the answer should be 60 because 60 minus 20 gives us 40. But let's just see if that is true using our method of solving. So here what we can do is we need to get rid of this minus 20. What is the whole objective? It is to make sure that x is on its own and we can see what x is exactly equal to in number form. Meaning we need to get rid of the 20, and how do we do that? We add both sides by 20, right? Because what you do on the one side of the equation, you do on the other side of the equation, so that this can cancel out, right? The 20s can cancel out and give you 0. And then we're just adding 40 by 20. And then we are going to say here that x is on its own, and it's equal to 40 plus 20, okay? Where x is just equal to 60. So there we go. That's how you just solve for x. And this was example 2, by the way. Got to say the number. So this is how to add and subtract both sides of an equation. So what if we would have to do with maybe multiplying and dividing both sides? So for this question, we have 3 times x is equal to 15. Now here we have x being multiplied by something, right? And my question is, what is the additive inverse of multiplication? By additive inverse, an example of this is addition is an additive inverse of subtraction. Why? Because they can cancel each other out. If I take positive 5 and I minus it by 5, I can give 0. And they can cancel out. Okay, and I can get rid of them. But what about multiplication and division? Well, think about this, right? If I have 3 and I am multiplying it by its reciprocal, which is 1 over 3, okay? This is a division type thing. Then, therefore, this can give us 3 divided by 3, which cancel to give us 1. So they are the additive inverses for division. Okay. Okay, otherwise, let's get into the example again. So, how do we get rid of this 3 times x? Well, whenever you see x being multiplied by something, you need to divide both sides by whatever the coefficient was. We need to get rid of that coefficient and get x on its own, like we did in the previous examples. So in order for us to do that, we need to divide both sides by 3, right? And why does this work? Well, now we have divided by 3, which we can write as 3x over 3. Okay, because we're dividing both sides by 3, and this is 15 over 3 as well. And then from here, notice that the 3's can cancel out, so that we have x on its own, and then we have 15 divided by 3, which is going to be 5. And this is true, because 3 times 5 is indeed equal to 15. Okay, but what about when x is being divided by something? So for this problem here, number 4, we have x divided by 3, or x over 3 in fraction form, which is equal to 5. Well, if we use intuition, we know that if we have 15 divided by 3, we will get 5. So we need to show that x will be 15, right? Because the last question we had to show that x was 5 in order to satisfy the equation, to make sure that it is indeed an equation where both sides are equal to each other, okay? So in this instance, how do we get x on its own and then get the number on its own on the other side? Well, think about the last question. When we had 3 multiplying by x, we divided both sides by 3. But in this case, we're having it divide by 3 now. So meaning we just need to do the other way around. So we need to multiply both sides by 3. Because it's the additive inverse, right? So if you see it being divided by some number, now you multiply it by something else. Okay. But if you see it being multiplied, we divide it by that same number. That is the coefficient, or whatever's underneath the variable. So if you multiply both sides by 3, notice that we get 3x over 3 because the 3 goes into the numerator, and then this is equal to 5 times 3, which is 15. Okay. And then notice that the 3's can cancel, and then we have x on its own. So x is equal to 15. So that's true. That's how we find x. So let's do one more example which adds everything into the spectrum. So here we have the fifth example. 2x over 5 minus 10 is equal to 60. Okay. So first things first, right? We need to find a way to get x on its own. But the easiest ways to start is always to make sure that the constants that are on their own need to be shifted the other way, or need to be eliminated from the side where x is. Okay, so we need to do it one by one. So the best approach right now is not to multiply or divide both sides by something to get rid of something from x here, but to rather get rid of this first, so that we are able to comfortably multiply and divide both sides without worrying about the two terms that are lying on the one side. So meaning, in order to get rid of negative 10, we need to add 10 by both sides. Okay, so that, notice, this will cancel and give us 0, because minus 10 plus 10 is 0. So 2x over 5 is what remains. And then 60 plus 10 is just 70. Okay. So here we left with 2x over 5. Now the best next thing to get rid of is this division. Okay. So the division, we need to get rid of the 5, meaning we need to multiply by 5. Right? If it's divided by 5, we need to multiply both sides by 5 so that we can get rid of that. So we multiply this side by 5, not 15. So therefore, what we have is 2x multiplied by 5 over 5, which is equal to 70 times 5, which should just give you 350. Okay. So then we can notice that the 5's cancel, and that is why we multiplied both sides by 5. And then what we're left with is 2x is equal to 350. And then here, we have 2x is equal to 350. In order to get rid of the multiplication, we need to divide both sides. So we're going to divide both sides by 2, so that we can get rid of the 2 multiplied by. Okay. So which means we're going to have 2x is equal to 2x divided by 2, because of the divided by 2 here, which is equal to 350 divided by 2. Okay. So this is just going to cancel out. The 2's are going to cancel. Then we have x, and then 350 divided by 2 should give you 175. If we were to check the answer, we would notice that 2 times 175 is going to be 350. 350 divided by 5, that one should give you 70. And 70 minus 10 is just going to give us 60, which we are left. Remember, look at the black one and not the red one, because that was the original. So notice how if we plug it back into the beginning, we do get the original 60 on the other side. Because it's always best to check whether your equations match up every single time after you've solved for x.